Hello, mathematicians, and welcome to today's lesson of virtual math class. Today, we're going to be talking about representing proportional relationships. So our objective for today is students will be able to represent proportional relationships, including what they look like and determining if it is a proportional relationship, which we kind of started in our lesson yesterday. So first things first, proportional relationships can be represented by tables, graphs, equations, or words whenever you're given a description. So let's look at this. First, we're given a description, and it says Jada and Noah counted the number of steps they took to walk a set distance. To walk the same distance, Jada took 8 steps. Noah took 10 steps. Then they found that when Noah took 15 steps, Jada took 12 steps. So right now we are given a relationship. So this is a relationship. We're going to see if it's proportional or how else we can represent this same scenario. Okay, so we're given the same description that we had on the last slide. That's all of this right here. That's the same information I just read. So number 1 says to create a table that represents this situation with at least 3 pairs of values. So if we need a table, so we're going to do X and Y. I'm going to let X be Jada and Y be Noah. So it tells us that whenever Jada took 8 steps, Noah took 10 steps. And then whenever Noah took 15 steps, Jada only took 12 steps. Now, this gives us 2 pairs of values. What would a third value be? How could I figure out what a third value would be? So there's a couple different ways that you could figure out. You could do what our next value would be on each side, or it tells us that they walked the same distance, which means that they would have started at the same spot. So they both would have started at 0, 0. And then that would give us 3 pairs of values. So number 2, it tells us to graph this relationship and label the axes. So remember that the axes would be, we would have our x-axis that's going from side to side, and then our y-axis that goes up and down. So on the side axis, the x-axis, I'm going to put Jada's steps, and on my y-axis then would be Noah's. So now they both started at 0, 0, or they both started at 0. So my first point would be 0, 0. Now, when Jada went 8, Noah went 10. So I'm going to go up by 2. So I'm going to have 2, 4, 6, 8, 10, 12, 14. And we're just going to keep going. And then the same on my y-axis, I'm going to go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and I could keep going. So when Jada took 8 steps, Noah took 10. So my first point is going to be at 8, 10. And now it tells me whenever Jada took 12 steps, then Noah took 15. So 15 is going to be right in the middle between 14 and 16. So then I would have my first line, and we're going to act like this is going to be so straight. That's not too bad, but it's not straight either. So then number 3 tells us to find the slope of the line. So to find the slope of the line, I need my vertical distance over my horizontal distance. So for my vertical distance, I'm going from, if I choose the point 0, 0, and 8, 10. So my vertical distance, I'm going from 0 to 10. So that would be a distance of 10. And then my horizontal distance, I'm going from 0 to 8. So that would be 8. So if I reduce that down, I could divide both of them by 2. And so my slope of the line, 10 divided by 2 is 5, and 8 divided by 2 is 4. So my slope is 5/4. So on this one, next we look at the equation. So the equation says to let x represent the number of steps Jada takes. So x represents the number of steps Jada takes, and let y represent the number of steps Noah takes. So our equation then is y equals 5/4x. So y equals 5/4x, because for every one step that Jada takes, Noah takes 5/4. So he's taking more steps. So now I want you to explain to me how you can tell that the equation, the description, the graph, and the table all represent the same situation. Because we just looked at a relationship that was represented in each of those ways, but they were each representing the same situation. So how can we tell that they represent the same situation? Okay, so on this one it says does the description and the table represent the same proportional relationship? So our description says that the Origami Club is doing a car wash fundraiser to raise money for a trip. They charge the same price for every car. After 11 cars, they raise a total of $93.50. After 23 cars, they raised a total of $195.50. So now I look at the table. The table, we have the number of cars and then the amount raised in dollars. So it tells me that after 11 cars, they raised $93.50. Does this represent that? 11 cars, $93.50. Yes, it does. That's the same thing. So now let's look at the next one. So it tells us that after 23 cars, they raised a total of $195.50. So now I look at the table. I have 23, and then I have $195.50. So again, that matches. So it would be the same proportional relationship because the description matches the table. Okay, so now we have proportional versus non-proportional. So proportional relationships are straight lines, whereas curvy relationships would be, non-proportional relationships would have curvy lines. So if you have anything that is not a straight line, if it curves in any way, then it would be non-proportional. Proportional relationships will be in the form y equals mx. So like y equals mx, where m is the slope and x is just our variable. So y equals 3x. You see how it's just 3 and x? Like there's nothing else there. So sometimes, so a non-proportional relationship would be y equals 3x plus 2. That plus 2 would make it not proportional. So then we have y equals 1/2 x. There can be fractions and it can still be proportional. But one that would not be proportional is if you see an exponent. So like y equals 5x squared. That exponent, or if you had y equaled 3x to the fourth. Anytime you see an exponent, that's going to make it curvy, which would make it not proportional. So y equals negative 7x. So again, we're allowed to have fractions. We're allowed to have negatives. All of those would still make a straight line. There's a constant slope. So if we look at a table, it would have a constant of proportionality. Non-proportional would not have a constant slope. So if we were looking at a table, it would not have a constant of proportionality. It wouldn't be being multiplied by the same. So proportional relationships start at 0, 0. So that point, the origin, it's going to start there. So non-proportional relationships would not start at 0, 0. So even if you saw a straight line, but it starts not at 0, 0, where our lines cross, then that would not be proportional. And that concludes today's lesson. Please remember to sanitize and be safe. I know that this is weird times right now, but we can do this together. So let me know if you have any questions or if there's anything that I can help you with.